Uh, Welcome to the first lecture in the module 4 in the subject hydrology and water resources. So by now we have started exploring the hydrological cycle, okay, and we have completed some parts like evaporation, transpiration, evapotranspiration. Then in the last module we also talked about infiltration. Okay. Now we will move ahead and we will talk about runoff. So what do you mean by runoff? Although I have gave a little bit information in previous lecture, but let's repeat it. So let us say if there is some river, okay, let us say this is some river, so let us say that this is some river which is flowing, okay, and this river gets its water from its source, also from its catchment area. So let us say that this red color, okay, this red color is some area, okay, and when rainfall occurs in this area, okay, so this area contributes water, okay, this area contributes water in this river or in this stream, and all this water can be recorded at some cross section. Let us say this is the cross section where you want to do your analysis. आप सारा जो डेटा रिकॉर्ड कर रहे हैं यहाँ पे आपने अपना सेटअप लगा के रखा हुआ है. So this is your basically your outlet. Okay, let us say that this is your outlet. Okay, so this is the catchment area for this outlet section. Okay, so whenever there is some precipitation over some catchment area, what will happen? Let us say that precipitation is quantified by P. Okay, then what will happen over the ground surface? Okay, if this is ground surface, some amount of water is coming in form of precipitation. Then what will happen? Some part of P, okay, will be abstracted by the ground. Okay, it will infiltrate inside the ground. So this P will break into two parts. First part is which is going inside the earth, okay, which is going inside the earth, that we call as infiltrated water, okay, and the other part, what will happen to the other part? It will simply flow over the ground. Okay, so this water will finally come and meet this river system, okay, or this stream, and you can record this water at this outlet. Okay, so the amount of water that you observed at your outlet is nothing but this water is nothing but the water that you are recording here. Okay, that is called your runoff. Okay, that is called your runoff. Sorry. So this water that is recorded here at the gauge station or at the outlet, here you have, this is called gauge station. Okay, जहाँ पे आपने अपना इंस्ट्रूमेंट या अपना सेटअप बना के रखा है, जहाँ पे आप कुछ भी चीज रिकॉर्ड कर रहे हैं, तो इस गेज स्टेशन पे जो भी वाटर इस रिवर में आ रहा है दैट इज बेसिकली योर रन ऑफ। रन ऑफ कैसे आ रहा है? जो भी प्रेसिपिटेशन हुआ, प्रेसिपिटेशन की वजह से क्या हुआ, सम वाटर विल फ्लो ओवर द सरफेस ऑफ अर्थ एंड इट विल फाइनली कंट्रीब्यूट टू ए stream or some river. Okay, so that water is called your runoff. Now it is very important to remember or to see that when you call it runoff, okay, there is one more term that usually confuses, that is called overland flow. Okay. So there is another term that's called overland flow, and sometimes people gets confused it as runoff. So there is very small difference. Okay, although people use these two words interchangeably. Okay, कभी-कभी यूज करते टाइम वो दोनों को एक ही जैसा यूज करते हैं, बट थोड़ा सा डिफरेंस है. सो व्हाट इज द डिफरेंस? दैट लेट अस से इफ देयर इज सम माउंटेन और देयर इज सम कैचमेंट एरिया एंड सम रेनफॉल इज occurring, then what will happen? Okay, let us say there is some river. So what will happen here? When water will fall here, some water will go like this and some water will be going like this. So this water that is flowing over the surface of the earth, okay, it becomes like a laminar flow. Okay, a slow, very smooth laminars of water flows in a manner. So this flowing water, which is laminar, okay, this is referred as overland flow. But when this overland flow contributes to the river and when it is recorded at some station, okay, then that water is considered as runoff. Okay, हालांकि दोनों एक ही वाटर है, बट दोनों में फर्क क्या है? एक को आप गेज स्टेशन पे रिकॉर्ड कर रहे हैं, एक क्या है आपका जो ग्राउंड पे फ्लो हो रहा है. ओके, इन ए लैमिनार काइंड ऑफ वे. सो दिस इज द वेरी स्मॉल डिफरेंस. ऑल्दो पीपल यूज दिस वर्ड रन ऑफ वेरी फ्रिक्वेंटली एंड दिस वर्ड ओवरलैंड फ्लो इज समटाइम्स सप्रेस्ड, बट यू मस्ट रिमेंबर दैट it is not the same. Now, assuming that you now understand what is runoff, okay. So, assuming that you understand what is runoff, then how will you quantify it? How will you find a mathematical value for runoff? Okay, कैसे आप mathematical value बता सकते हैं कि कितना वॉल्यूम है या कितना वाटर है, इसको क्वांटिफाई कैसे कर सकते हैं? सो इट इज वेरी सिंपल. व्हाट यू कैन डू, you come to this gauge station, you measure the cross sectional area of this stream. Okay, then what will you do? Let me draw another diagram. So let's say you are at the gauge station, okay, you are at the river side, and what you have to do, you just have to measure the cross sectional area of river. Okay, let us say this is cross sectional area. Okay, this is cross sectional area of the river. Now what you can do, you have to simply check what is in this area. You just have to fix one staff. Okay, you can put one staff here, one surveying staff. Okay. So when water will flow in the stream, what will happen? This water will start rising. Okay, it will come here, then here, if water is rising and precipitation is going up. So you can note down these readings. Okay, so based on these readings, you can tell, okay, what extra water is coming to the stream. So where this extra water is coming from? This is coming from the precipitation, okay, when rain is happening. So this amount of water is nothing but your runoff. Okay. Also, usually you express runoff and precipitation in terms of depth of water. So that is why we are using this staff, and we are directly saying runoff in terms of depth. Okay. Although the cross-sectional area of river is not this much regular, it is some different shape, okay, some non-regular shape. Okay, so that can be converted. Okay, so for that is a different part, but for us it is important. For us, the very important thing is that both are expressed in terms of depth. Okay. Now what you can do is you can calculate the value of discharge, okay, here in this cross section area of your gauge station, okay, cross sectional area of your stream where you have set up your gauge station. You can calculate the discharge at that particular section. Okay, so how can you calculate discharge? So you can simply use some devices. Okay, sometimes at dams also, where you set up your dam, you can open the gate and you have formulas for gate, that if gate is 2 gates are open, then this much will be discharged. 3 gates are open, this much will be discharged. This much is the depth of water. You have some formulas, you can derive that. You can set up a weir, okay, concrete weir. You can also set up to calculate these values. So there are multiple ways of calculating the discharge. You might have come to this in the subject fluid mechanics, how to calculate discharge. So the important thing is you have to calculate the discharges. Okay. So once you calculate the discharge, the discharge actually representing your runoff. Okay. Discharge is basically representing your runoff values. So let's say that if you are trying to draw a graph, okay, when you are drawing this graph, when there is some rainfall is happening, some precipitation is happening, and what you have done, you are at this station. You have set up your staff and all your devices, and when rainfall is happening, you are simply checking what is the value of discharge at this cross section of the river or stream. Okay. So what will happen? So if this is some Cartesian system and you put discharge here, okay, and you put some time, so when rainfall just starts, okay, river must have some discharge. Okay, when rainfall is before the beginning of rainfall, I should say, there must be some discharge in the river. That means some discharge will be in the river. So when there will be a rainfall, okay, so what will happen? Some water will flow in the catchment area. Okay, some water will flow in the catchment area. Okay, when rainfall will happen, some water will flow inside this river. Okay, and you are going to note those discharge at this cross section. So as the time progresses, okay, so there will be rise in the discharge. Okay, so you will observe that this discharge will start rising. It will start rising, and after a certain point, when rainfall stops, okay, when rainfall will stop, what will happen? Discharge values will simply start decaying. Okay, it will start decreasing. So after some time, when rainfall has stopped, this discharge will again fall down, and again a constant value of discharge will be maintained. Initially जो discharge था वही discharge finally भी maintain हो जाएगा. ये जो extra amount of discharge आया है, ये किसके वजह से आया है? This is because of rainfall. So if you could observe that this much area of this graph, okay, is because of precipitation is nothing but your runoff. Okay, is nothing but your runoff. So if you calculate this area, this shaded area, calculate this area, so what will be it will be discharge, okay, into time. So it will be nothing but volume. So it is what volume? It is volume of runoff. Why runoff? Because this extra water that is coming inside a river is because of your rainfall. Okay, that part of rainfall which is contributing to the runoff. So this is your runoff. So what you have to do, you have to go to a river or some stream. You have to select your gauge station, you have to set up your devices, and you should wait till rainfall happens. When rainfall happens, you simply have to calculate the discharges. Okay, you just have to keep noting down your discharge values, and you can draw this graph. And then after drawing the graph, you have to draw this line. You have to remove this much amount of water, and this much area of the graph is nothing but your runoff volume. Okay, now this graph is nothing but, okay, this graph is famous by the name that is called Hydrograph. Okay, so they call that hydrographs are the tools to calculate the volume of runoff. Now if you observe that this area, okay, this area in the graph, what this area, this amount of discharge is basically from origin. Okay, what is the origin of a river? The origin contributes some water to the river, and that water is this green shade. So this this discharge is called, okay, I should say that this amount of discharge is called QB, and it is called base flow. This is base flow of river, which is usually a constant value for a particular season. Okay, हर सीजन में ये base flow की वैल्यू एक फिक्स होती है. So this is your base flow, and this much area is your runoff. Now when you understand this graph, now very important question that I should ask, that when should this graph, okay, should start decreasing. Okay? कब ये ग्राफ में डिस्चार्ज नीचे जाएगा? Okay? What can be options? First option can be when rainfall stops. Second option can be after some time when rainfall stops. Third option can be before some time when rainfall stops. Okay. This can be three options. So you may pause the video and you may think of it that when it should start decreasing, the discharge should decrease at what point of time. So assuming that you have done your analysis, so let me bring you back to this diagram. Okay? So if you see this diagram, okay, so let's say here that rainfall happens for 30 minutes. Okay, let's say that duration of rain, let us say 30 minutes. So what will happen? You are recording runoff at this outlet or at this gauge station. Then there is some possibility that the water which is here, okay, which is the farthest point in this catchment area, and it has to travel like this. Okay, it has to travel like this. So the important point is that if this water has to travel up to this point where you are recording all this data and you are drawing the graph, this value can take more time than this 30 minutes. Okay, it may, when some point is closer, it will take lesser time, but the farthest, let me change the it like this. Okay, let me change it like this. So if this kind of catchment area is there, so if some rainfall is happening here, okay, so water that is falling here will take longer time or longest time to reach here, and this time can be greater than your duration of rainfall, which also means that this particular point or this particular time, okay, this particular time is not when the rainfall stops. Rainfall will stop at some point here or somewhere in this side of the graph, okay, not here. Okay, up to certain time, that must be duration of rainfall. Okay, that must be there. Now, assuming that you understood that, the time which the particle of water, okay, takes to reach from the farthest point in the catchment area to the gauge station is called time of concentration. So I will write here, it is called time of concentration. What is time of concentration? It is time taken by water from farthest point in catchment area to gauge station. To gauge station. So to travel from so the time which the water takes from the farthest point, okay, to the gauge station, that time is called your time of concentration. So the fact is that time of concentration usually is greater than the time of rainfall. Okay. That also means that that also means that this is not your duration of rainfall. This particular time is not, this is not TR, rather it is nothing but time of concentration. So it is very important to understand that. Now you see this curve is rising like this and then it is decaying again. So what could be the nature of this particular line? Let us say I break this graph in two parts. Okay, let us say I break this graph in two parts from the P, and I call this one as, rising limb, and this one after this point I call this as falling limb. Okay, when the hydrograph is decaying. So on what properties does this rising limb depends? Okay, what will be the nature of the curve? 2 डिग्री होगा, 3 डिग्री होगा, 4 डिग्री होगा, एक्सपोनेंशियल होगा या लॉगरिथमिक होगा, कैसा होगा? ओके, ये किस चीज पे डिपेंड करता है? सिंपल सा क्वेश्चन ये है. सो द आंसर इज दैट now I will write it as a note that rising limb depends on catchment area plus the रेनफॉल. ओके, कैसा रेनफॉल हो रहा है, रेनफॉल की प्रॉपर्टी क्या है, उसकी इंटेंसिटी क्या है, इन दो चीजों पे मेजरली डिपेंड करता है. पर जो फॉलिंग लिम्ब है, फॉलिंग लिम्ब डिपेंड्स ऑन only on catchment area, okay? Not the type of rainfall. क्योंकि जो राइजिंग लिम्ब बना ही है कब, जब रेनफॉल स्टॉप हो चुका है, उसके बाद भी ग्राफ डिके कर रहा है, ओके, फॉल कर रहा है. सो the type of rainfall that has happened do not contribute to the falling limb. Okay, so it is very simple. Also the hydrograph that we have drawn here, it may follow some shapes. Okay, like I'm just giving example that it may be like this, then let's say it is like this, okay, or it may be like this. So these shapes, okay, that how these shapes are quantified, or what does this shapes represents, and how these shapes comes, or if you want to predict these shapes, so how can you do that? Okay, on what factors does the shape of hydrograph depends on what type of catchment will lead to what kind of hydrograph. Okay, so this we will talk in the next lecture. So this is all for today's lecture. I hope you might have learned something from it. So thank you very much. We'll meet in the next segment. Thank you.